Hey, welcome back to my YouTube channel. I am Xavier Smith, and today I'm going to be talking about net ionic equations in chemistry. So let's get started. What we're going to use for these are DRR equations. You can use SRR, so double replacement reactions or single replacement reactions, but single replacement reactions are just like a little weirder, and I'm just going to work on double replacement reactions. Okay, we're just going to do one example, and all you can get from this is, well, net ionic form. You can get that clearly net is like the end result. Like there's probably going to be things canceled, right? It's just like, what do you really need from this equation? And then ionic, clearly you're going to turn things into their ions, and then form. Okay, so you can get from the name that there's going to be things like canceled, right? And then it's going to be in ionic form. Okay, so what you're going to need for this is solubility rules. You're going to need to know those. There's going to be another video I've made about those, but I'll just walk through this problem telling you the rules. Okay, so magnesium nitrate and sodium chromate. So clearly this is double replacement reaction, and we have to get from the words to the symbols and then balance, and then find the other side. Then find the other side of the equation, then balance, and then turn into ionic form. So let's go. So magnesium is a 2 plus, nitrate is a 1 minus, so we have MgNO3 twice, plus sodium chromate, chromate's a 2 minus, sodium's a 1 plus, so Na2CrO4, and then that would yield, we're just going to switch these metals, so it'll be NaNO3 and MgCrO4. So we have magnesium nitrate and sodium chromate yields sodium nitrate and magnesium chromate. Okay, so solubility rules. If you have any nitrate, nitrite, chlorate, and there's another one, are always soluble. So if you ever see nitrate or nitrite, just say, okay, that is soluble. And what soluble means is that it kind of dissolves in, like if you put it in water, it dissolves, right? There's no precipitate at the end, like little solid chunks. There's nothing. So what we say here is that's AQ, aqueous, like it's in water. So we say that is AQ. Okay, and then Na2CrO4, sodium chromate. Well, if you have any like group 1 metal here, like sodium is a group 1 metal, then it is aqueous, like it can dissolve. So AQ. Then NaNO3, of course, you have a group 1 metal and you have a nitrate, so that's also an AQ. And then you have magnesium chromate. Magnesium's a group 2 metal, and chromate's just a random metal that doesn't really dissolve unless it's with like a group 1 metal or ammonium. But we're just going to have to call this a solid. And if you just think about it, magnesium chromate, you're like, that does not sound like it could dissolve in like water. And I don't think it would either. It sounds like a metal. So we're going to call that a solid. And this is what most double replacement reactions are. You have two aqueous things creating an aqueous and a solid, or you could create like water and carbon dioxide, which water will always be labeled L as liquid, and carbon dioxide, of course, is a gas. Or if you create like ammonia, it's gas. So you use aqueous solutions, and you create like something aqueous, and then you create something that's not aqueous, a solid, liquid water, or a gas. And the gases, all you really need to know is like ammonia, CO, CO2, because they're just normal ones. That's everyday life. Okay, so what you do here is you split these, everything that's AQ, into its ions. So this would be first you have to balance. I don't know what I'm thinking. There's one Mg here, there's one Mg here. There's two NO3s here, there's one NO3 here, put a 2 there. There's two NAs here, two NAs here, CrO4, CrO4. We're good. So Mg, and you put it ionic form, 2 plus, right? And then we bring the little AQ here. And then plus, there's going to be, you don't say NO3 little 2, right? You bring this subscript out front, 2NO3 negative AQ. Of course, you keep the NO3 together, like the O3 together with the N. You don't split, well, like N negative and O3, 2 negative, because NO3 just is one of our compounds, so we just keep it together. Okay, and then plus, this is AQ as well, so we split it apart. 2Na, this is plus AQ, plus there's one CrO4, CrO4, 2 negative AQ. And then I have to go down to the next row, so this is going to be a little weird. And then this 2 distributes to the Na, so we have 2Na plus AQ. Remember, ionic form, keep this ion here. You have to have the plus, or it is something totally different. It's just like an atom of sodium versus sodium ion. Totally different. Okay, and then there's NaNO3. So there's 2NO3 negative AQ. Like if you had Cl and you just said like plus Cl, right? Instead of plus Cl negative, you have to say plus Cl2 because clearly in nature, chlorine's diatomic, so it would be Cl2. But if you add that little negative there, it becomes an ion, and that's not diatomic because it's not just the atom, it's an ion. So make sure you add these charges or else you're wrong. And if it's in Hibberfunkel, meaning it's diatomic, then you're especially wrong. Okay. And then this is not AQ, magnesium chromate, so we're just going to say MgCrO4. No need for charges there because like it's already put together. This is 2 plus, this is 2 minus. Okay, now what you do is this is called complete ionic form, and net ionic form, you're just going to subtract the things that are the same on both sides. So look for these like floating floating ions. There's 2 NAs right here, and there's 2 NAs because this is one side, this is the other side. So 2 Na plus AQ, 2 Na plus AQ. So cross those off. But if you're asked for complete ionic form, clearly give this. Then we have 2NO3 negative AQ, and we have 2NO3 negative AQ. So we cross those off. And now there's nothing else to cross off. That's the same on both sides. So we have Mg2 plus AQ plus CrO4, 2 negative AQ goes to MgCrO4 solid. So this is what we really need. These are the two things that are really reacting together. These other things, this nitrate and the sodium, they're called spectator ions. They just sit in the stands and they watch. They're there to help the chemical reaction. Like they just change their chemical formula and then they're good, right? They're just done. They're just sitting in the solution. They're just ions and they're the same on both sides. So you don't really need them. Like you need them for the reaction, but they don't help in the reaction. They're just there to like supply this magnesium nitrate. The nitrate's only there to supply the magnesium. And sodium chromate is only there to supply the chromate. And then the sodium and the nitrate is just like, it doesn't matter. They're just gone afterwards. So it didn't take place in the reaction too much because this is all we really care about. So this should be your final answer. And net ionic form should be like AQ plus AQ yields a solid. If you do an SRR, a single replacement, you're going to get like, things aren't really going to cancel. You're going to get like AQ plus S yields an S plus AQ or something. It's just going to be strange. Okay, well, I hope this video was helpful. Please leave any comments below and subscribe if it was helpful. Like the video. Thanks for watching.